Today's assignment is kind of a combination of several things we've done since pretty much August when school started through domain and range. And then more recently, your axis symmetry, vertex, increasing, decreasing. X-intercepts we hadn't talked a whole lot about, but that's about to happen. Those are called zeros or roots or solutions and X-intercepts. So let me go through one of these. A lot of it is review, and it's just kind of to put everything together. And then I'll go to the back page where there's a word problem and kind of get started on that and let you finish that off. So probably the first thing I would do is put this equation in y equals to see what we have and what's going on and get a picture of it. And then we can get everything probably from the graph and the table. So negative x squared plus 6x minus 2. And probably the first thing I want to do is graph that thing and see what it looks like. So we've got a graph here. Might want to grab a few points, but it's pretty close. So get it kind of close to where it crosses things and where the vertex is. Looks like 1, 2, kind of 3-ish, maybe 4, 5, or 6. Yeah, we'll go to table. Let me see if I can go to table. Let's see if we want to go back, don't we? I ran right by it, didn't I? There we go. 3, 7 is your vertex. If you'll notice, there's a 6 on either side of the 7 and a 3 on either side of the 6s. So 3, 7 is my vertex. So I can put that in right now. And so 3, 7. Hard to move this thing around with a mouse. It kind of goes down this direction. Kind of curves down this direction. So the accuracy of the graph is not necessarily really important. The vertex you probably need to get, and we'll find the zeros or the roots. The axis of symmetry is going to be this imaginary line that splits the parabola into two parts, and it happens to always be the x coordinate of the vertex. So the axis of symmetry is x equals 3. The y-intercept, not sure it's an integer or not. Let's see. Yeah, so the y-intercept is when the x value is 0. So negative 2 is my y-intercept. Domain on all parabolas, if it's not in a problem-solving scenario, is all real numbers. So you can use that all real symbol. The range, well, the highest y value it goes to is 7, and it points down. So the range is all the y's smaller than or less than or equal, symbol out of that, to 7. And the x-intercepts, we'll come back to that. Let's go with the increasing, decreasing. The x-intercepts, I think I'm going to have to use my second trace feature because they look like they're decimal x-intercepts, which is fine, not a problem. Somewhere between 5 and 6, and then somewhere between 0 and 1 because that's where the signs change, so it crosses in there. So we'll come back to that in just a second. So the increasing, the idea is, let's see if that does a little. As you're working from negative infinity on the x-axis to positive infinity. So as you're going this way on the x-axis, we want to know what is the picture of the graph doing. And so the graph, if it's pointing up, kind of like a slope maybe, if the graph is going in an upward direction, I know these arrows point down, but you kind of just have to look at the line or the curve of the graph. So this is going in an upward direction. So it's increasing, going towards the positive until it gets to right here at the vertex. And then it turns and starts going negative. So as I go from negative infinity to 3 on the x-axis, this graph is increasing in value. So from negative infinity to 3, the graph is increasing. And then at 3, it makes a turn, and forever after that, which is infinity, it's decreasing. And so you may or may not notice there's a lot of 3's in here. And so this x coordinate of the vertex gives you a lot of information. And the increasing, decreasing, that x coordinate of that vertex will be in there. It's just a matter of is the graph increasing first or decreasing first. And so that's how you come up with those. The x-intercepts, let's go back to the graph. And we'll use our second trace. We've used this second trace for intersecting lines way back in September, October-ish. You may have used it for maxes and mins to find that. This is a 0, so option 2 is what we want. And we have to trap it below and above, so the cursor is already below. Press enter. And then I just move above the x-axis. And I press enter and enter a third time. So this one's like 0.35 is one of the x-intercepts. And I should change that pen a little bit so we get some contrast. And then I go to second trace again, 0, option 2. And this time I'm going to go above and below. So left bound is above and below when it's going down, and when it's going up, it's below and above. So just move the cursor over, get it kind of close. Press enter, and then go down below. And we press enter, and then enter a third time. And 5.6-ish is my other x-intercept. And so that's what you do with each one of those. In the table over here, I don't care which values you pick, just pick some values, go to second graph. If you want to start with 0, 1, 2, 3, 4, 5 on all these, I don't care. It doesn't matter. Whatever numbers make you happy, just fill in the table so that I know you've looked at the table and gone through it and put some values in. And then you fill in the y values on those. So that's what you would do with each one of those graphs on these first couple of pages. And you may have to use second trace zeros on all of them. I don't recall if they have integer values or not. But that gives you an example of some of those. Of course, if they're in vertex form, the vertex is already there for you. I don't know if you've realized that yet, but the vertex is opposite of what's in the parentheses and face value here. So the vertex on this one, without even knowing what the graph looks like, is -1 and 1. Now you still probably want to graph it so you can see where that thing is. It's going to open up. The axis of symmetry then is going to be x equals -1. And then I'm not sure on the y-intercept. The domain I know is all real. You can put that in all of them if you want. It's supposed to be like parallel lines with a kind of R wrapped around it. I know it's having a hard time making that. The range is also going to be from this 1, and since it's opening up, it'll be y greater than or equal to 1. And then, of course, the x-intercept, you'll have to look at the graph and figure that out, the increasing, decreasing. But that's a little bit of information just by being in vertex form. I can grab out of that information. So let me go down here to the word problem. I'm not going to do all of this, but I'll kind of help you set it up a little bit. Anytime you have a table of data, this 1, 2, 3, 4, 5, and then these 12, 18, 28, 42, 60, those are going to go into stat edit, and it tells you it's a quadratic function. Didn't mean to cross those out. Looks like I'm crossing words out. Sorry about that. Trying to underline quadratic function. So it's going to be a quadratic function, and that tells you what stat calc you're going to use. And so your L1s will be the 1, 2, 3, 4, 5, and your L2s in stat edit will be the 12, 18, 28, 42, and 60. And then it does ask you on there to graph it, so I'd probably just make each of those lines 1. You don't need the whole graph, and you really only need the first quadrant. because this is measurements, and measurements do not go negative. So even though the graph's going to go negative, we do not go negative in this problem-solving scenario, which restricts the domain. It's the graph is all real numbers, but in this situation, we can only use positive numbers. It's probably just easier to count each line as 10. So the second line would be 20, it'd be 30, this would be 40. You can count it whatever you want, but that seems to be the easiest. And then we can plot those in there. So at 1 would be around 12, so just a little bit above the 10 mark. And 2 would be 18, so close to the 20 mark. 3 is 28, it's real close to the 30 mark. 4 is 42, a little bit above. And then 5 is 60, which is up here. So kind of the idea is it's going to give you a curve and an increasing value. So when you graph that, just remember that you got 60 right here, so you're going to have to open your Y max up to 60 or 70, probably 80, just to see what's going on. So you get the correct graph. So leave your X max alone, leave it 1 to 10, but open your Y max probably just to 80, just so you can see what the graph's doing. And those are things that you have to pick up on as we go throughout the year. You have to look at your data so you can see how much of the window you need to use. And then from that, you can get this other information and see what you can come up with on there. So that'll kind of get you started. This will take today, and I doubt we'll finish it in class today, so it'll go into tomorrow. There is another shorter assignment tomorrow, so things will hopefully get completed tomorrow, which will make this thing due on Friday. You also have a warm-up quiz. Make sure you get that completed in the next day or two, and stay current on your grades. So have a great day.